So before starting this video, I'd love to thank the sponsor of this video, which is Code Studio. Now, if you are willing to practice interview problems topic wise, this is the place where you should look for, because Code Studio has over 2000 plus problems and has all the problem solution in C++, Java, as well as Python. If you're looking for a guided path, then you can find for Python, for DBMS, for object-oriented programming, operating system, computer networks, system design, web development, any other thing that you're looking for, you'll find guided paths for every other thing over here. Also, if you're looking for any top company questions, let's say if you have an interview at Amazon, if you're looking for Amazon questions, you can get all the top Amazon coding questions via tag and all the solutions in C++, Java, as well as Python. Also, if you have an interview schedule, you can read their interview experiences, where there are 600 plus interview experiences from companies like Amazon, Microsoft, Adobe, Google, etc. So what are you waiting for? Code Studio has a lot of free resources for interview preparation. The link will be in the description. Make sure you check it out. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today will be the lecture 2 of Recursion playlist, which is basic recursion problems. Now in the previous video, we did learn about recursion in depth, what is like. So please make sure you watch out the previous video, and after that only you start this video. So in this video, we are going to solve some problems. The first one being print name 5 times. I'm assuming you can do that. Print linearly from 1 to n using recursion, definitely. Print linearly from n to 1. Then print linearly from 1 to n, but in some backtracking. Over here, I'll teach you how can you do stuffs using backtrack. And print from n to 1 again using backtracking. Okay, so I'm assuming you can do the first 3, but still I'll recommend you to watch the entire video, because the concepts gets more clear the more you watch the videos. So let's take the first problem and do it. That is print name n times. Let's keep it n times. Okay, so the generic way is definitely to run a for loop and print the name n times, but I want you to print your name n times using recursion. Yes, that's the catch here, using recursion. So how can you do this? You know, there will definitely be a main which will be calling print. Okay, so I'm saying n times. So what you can do is you can take the n from the user. Yes, you can take the n from the user. So input as n. In Java, it will be integer.parseInt n, and then you can say a function with probably 0 and n. So over here, I'm gonna teach you something which is very important, 1 and n. So this is the first time, and I'm saying till n you print it. Okay, over here I'm gonna teach you something, change of parameters, which is very important. So I'm writing a void f. Okay, no global variables this time. I'm taking an integer I, and I'm taking an integer n. Okay, over here I know the base case is if I start from 1, I have to go till n. That's for sure. Like I have to print it n times. So I know the base case is definitely going to be till I haven't printed n times. So if at any moment I exceeds n, I'm going to say return, because I'm going to just print it n times. That's very simple. Coming from the previous class, it's very, very simple. This is what we call it as the base case. Remember? So base case is decided on the problem statement. So this is the base case. Okay, what after that? After that, I will be like, okay, let's print it. So you will simply say print, let's assume my name is Raj, so I'll print Raj, and then I'll call f. I've printed it once. I did came up as 1. So the next time I will call it as I plus 1 comma n. Okay, so let's understand how does the flow works, so that you get a better perspective. So initially you'll be taking integer n. Assume n is given as 3. Assuming n is given as 3. And again, I'll put the output screen over here. Assuming n is given as 3. So n becomes 3. Function says 1 and n. So this guy calls this particular guy with i's value as 1, n's value as 3. So the function call, yes, the first function call that you make is of f of 1 comma 3. That's the first function call you made. Is the base case true? No, because 1 is not greater than 3. 1 is not greater than 3. No. Thereby, you say print Raj. So Raj gets printed. Okay. Next, you're saying function of I plus 1. So this guy calls a function with I plus 1. I was 1 over here. I gets incremented by 1 and calls the function by 2 and n is still 3. And over here, you write the same line of code, I greater than n, because it's the same function which is being called. So in memory, it's the same one, print Raj, and then f of I plus 1 comma n. Okay. This time, let's understand if this base case is executed. I is 2, n is 3. So this will not be executed. Print Raj. Again, you print Raj, right? Remember this function of 1 of 3 called this f of 2 3. So in recursion tree it will be f of 2 comma 3. This is how you create the recursion tree. Now f of 2 3, this is printed, and now this portion. So this guy goes and again calls f of I plus 1, so 3 comma 3, and again you write the same lines, is I greater than n, then you say return. Definitely this is false. So thereby you again go and say print Raj, and you say f of I plus 1 comma n. So this is false. So this gets executed. So Raj is again printed. F of I plus 1. So this time f of 2 3 called f of 3 3. So I can just draw that f of 2 3 called f of 3 3. Now f of 3 3 calls I plus 1, which is f of 4 comma 3. And this moment I can say if I greater than n, then return becomes true. Why? Because I is 4, n is 3, and this guy comes out to be true. Thereby you are returning. So the moment you're returning, these lines will be of no use anymore. These lines will be of no use anymore. So you return. Now this is done. Now remember f of 3 3 called f of 4 3. So you can do it in the recursion tree as well. F of 3 3 called f of 4 3. Okay. So this is done. This is over. So I can say this function is over. Thereby you can return. This is done. So this function is over. Thereby this is over. You can return. Thereby this is over. You can definitely return back to where it was called. And now the function, the program terminates. So this is how easily the recursion did work, and we did it in the parameters and not using any global variables. So I was able to print my name n number of times. Yes, I was able to print my name n number of times, and at f of 4 3 I returned. So this got completed, this returned, so this got completed, this returned. So during the course, this guy printed 1 Raj, this guy printed 1 Raj, this guy printed 1 Raj, and this guy hit the base condition and returned. So this is how you can easily do the first problem, which is print the name n times using recursion. Right? I hope you have understood this. So if I talk about the time complexity, space complexity, it's very, very simple. I can say the time complexity to be big O of n, because inside the functions, yes, inside the functions, these lines are like big O of 1, like they don't take any time. So apparently you're calling one function, that guy calls one more function, that guy calls one more function. So you're calling n functions. If you carefully observe, 1, 2, 3, 4. So you're calling n functions, like near about n functions. So I can say the time complexity to be big O of n. Yes, I can say the time complexity to be big O of n. And what is the stack space? So in space complexity, we generically assume the stack space. Now this guy would have been in the stack when you called. F of 1 comma 3 would have been in the stack. Then f of 2 comma 3 would have been in the stack. Then f of 3 comma 3 would have been in the stack. So they were waiting in the stack till this base case return. They were waiting to be completed. So thereby I can say the space complexity is also big O of n. Now this space complexity is hypothetical, like you're not using an array. Internal, the computer's internal memory uses the stack space So thereby making the time complexity and the space complexity to be big O of n and big O of n. I hope that makes sense. So guys, we have done the first problem, which is print the name n times or 5 times. Okay. Now let's do the next problem, which is print linearly from 1 to n. So basically, if n is given as 4, I want you to print 1, 2, 3, 4. Yes, this is what I want as the output. Okay, so how will you do this? Again, very much similar to the previous problem. If I write down the function, it's going to be I comma n, and it's going to be I greater than n, and you're saying return, and this time the print statement will be executing I, and then you can call f of I plus 1 n. It's a similar one, just in place of the name you can print I, right? So that in the main, yes, so that in the main, when you call the function, like you can take the input of n, you can take the input of n, and then when you call the function with 1 comma n, first time prints I, which is 1. Next time goes I plus 1, so 2. Similarly, you can just go on printing till whatever your n is. So it was quite similar to the previous one, where I'm easily able to print 1 to n, correct? Now it's a time to think it in the reverse order and do the next problem, which is print in the opposite fashion. Print in terms of n to 1. So like if I give you n equal to 4, you're going to print me 4, 3, 2, 1. Now, can you do this? Can you do this? I think you can. Yes, you can. It's very simple. As of now, the code that we wrote started from I equal to 1, and then you did I plus 1, then you did again I plus 1, and you kept on calling. So if I have to print from 4, I can understand that the first I has to be 4 and the last has to be 1. After 1, before 1 you don't print. So I can say I'll just write the function in the opposite order. It's going to be same I comma n, but this time it's going to be if I becomes lesser than 1, then I don't need to print, and I can print the I, and this time I can call it I minus 1 comma n. And during the start, yes, I repeat, during the start of main, I can take the input of n, definitely. I can take the input of n, and I can say f of n comma n to be called. Yes, I can say f of n comma n to be called. So that if assume n is given as 4, the first time, or assume the n is given as 3 to have a better understanding, the first time you call it 3 comma 3, and this calls it like 3 comma 3, correct? This line doesn't executes, print 3. So the output screen will definitely have something like 3, and then you call it as f of 2 comma 3, and again then you will call it as f of 1 comma 3, and again at the end you'll call it f of 0 comma 3, and this 0 comma 3 will be executed, and you'll come back, you'll come back, and you'll come back. So automatically you print 3, 2, 1, as simple as that. So it's the main stuff is you just change it over here, where you say I'm going to do I minus 1. This is the main stuff where you change, where you say I'm going to do I minus 1, correct? So again, we have also done the next problem, which is print in terms of n is to 1. So 3 problems have been done. Now these were very basic. I want you to change it and think it in the reverse order. What if I want to print from 1 to n, but I don't want to do I plus 1. Instead, I say that the recursion call starts from n comma n usually. Like to give a better brief, let me just explain. I'm saying print from 1 to n, print from 1 to n, but I am not going to allow you to use plus 1. Like generally from 1 to n was meaning f of I plus 1 comma n was the function call, was the recursive function call that you are making. I'm not allowing you to do that. I'm not allowing you to do plus 1. So how will you do this? So over here I'm going to teach you something as backtracking. Okay, so let's understand backtracking. Since I'm not allowing you to use plus, you have to use minus. So what I'll do is I comma n, okay, as usual. This time it will be like if I at any time goes lesser than 1, you return f of I minus 1 comma n, and right after that I'm writing print of I. Okay, so over here I'm writing the main function. Over here I'm writing the main function, and what I'm writing is, okay, main, let's take the input of n and let's call f of n comma n. So basically what I did was I said that you cannot use this plus, thereby you can use minus 1. Why? Because I wanted me to teach you what if I write the print line after the recursion call. What happens? Let's understand. So again, let's quickly give the output screen and assume n is given as 3. So the first call is 3 comma 3. Thereby the first call goes as 3 comma 3. The first call goes as 3 comma 3. Now let's understand this. Does this line execute I lesser than 1? No, because I is 3 and it doesn't execute. Perfect. Next, I'm saying f of I minus 1. So this function call will go. Remember this. The print line will not be executed. The function call will go. Perfect. Let's call the function call, and I'm saying I minus 1. That's 2 comma 3. And again, let's write if I is lesser than 1, then return. And let's write f of I minus 1 comma n. And then let's write the print of I and then this. Okay. So let's see if the first line executes. Again, no, because I is 2. Doesn't. This time again you call the function with I minus 1, which is 2 minus 1, 1, 1 comma 3. And this time you write if I is lesser than 1, you return. And you say f of I minus 1 comma n, print of I. Okay. Let's see what happens this time. F of 1 comma 3, I is 1, doesn't executes. F of I minus 1 goes and calls this. With f of I minus 1 means 0 comma 3. If I lesser than 1, return. I'm not writing the remaining couple of lines. I is 0. So this line this time is indeed true. Is indeed true. And if this line is true, what happens? You basically say return executes. So you return. So this function line has been executed. Correct? Now the print comes over here because after this, the line of execution comes over here and it says print I. What's the value of I? 1. So the output will be 1. Next, the execution line comes over here, which means the function has been executed. Correct? Go back. Went back. This line has been executed. Thereby the function line comes to the next. This print is I. What's the value of I? 2. Printed. Next, the line of execution goes here, which means this function has been executed. Go back. This has been executed. Go to the next. Print I. I's value is 3. Thereby this line has been executed. Go here. Hence go back. So even by starting from 3, I was able to output in the linearly increasing order. So it's not necessary that you have to start from 1 in order to print from 1, 2, 3. You can start from the back and you can do the task after the function call. So basically, by doing this, what you did was you made it mandatory that this print line is executed at the first, because you kept it after the function call. So unless and until this function call is over, this line would have never been executed. So you made sure the last guy has been executed first. Why? How did you make sure that the last guy, because this was the last guy, has been executed first? How was this function completed first? By making sure the print line is after the function call, because this will only be executed if the base case is true. Thereby this gets executed, this then this gets executed, then this. That's the opposite way you made it, by writing after the function. Got it? So this is how you print from 1 is to n. Now I will be asking you to do the other one. So this is what I've done, but by backtrack, this has been done. I want you to do the other way. I want you to print from n to n. Basically, if I give you as n equal to 3, I want you to print 3 to 1, but I don't want you to use this I minus 1 comma n. I don't want you to use this. Okay, so I will not solve this. I want you people to answer in the comment section about this. Let's see if you have understood the entire concept. You should be able to do it. Yes, you should be able to do it. So remember, if I write this as a recursion tree, it's very simple. You started with f of 3 comma 3, then you went to f of 2 comma 3, then you went to f of 1 comma 3, then you went to f of 0 comma 3, which indirectly stated I'm over. Then the print line executed of 1. Then you said, after this the print of 2 was executed, and so this the print of 3 was executed. So this is how the recursion tree will look like for this particular stuff. So I hope guys you have understood all the problems, and you have understood the recursion in depth for the basic kind of problems of 1D recursion. So just in case you did, please make sure you like this video, and if you're new to this channel, please do consider subscribing. And yeah, if you haven't checked out our Strivus SD sheet, the link is in the description. Please make sure to check it out. With this, let's wrap up this video and meet in the next one, where I'll be discussing some other interesting problems. Bye bye.